Hello and welcome back to Lesson 16.4, Comparing Linear and Exponential Models. This is a lesson a part of Algebra 1B, Credit 5. So in the first lesson we learned about first differences. As you can see here from our table of values, the first differences are not the same. We then we learned about second differences, and we found that the difference between 4 and 2, 8 and 4, the difference between 16 and 8, and 32 and 16 are not the same. Hence the label here. Second and first differences are not equal. However, if we do one more thing, which is our new word, ratio. Ratio is just when we divide the second term by the first term. So if we divide 4 divided by 2, we would get 2. 8 divided by 4, we'd get 2. 16 divided by 8, 2. Noticing a pattern here? Yes, because all of these are equal. That would make this function a new word, exponential. We kind of reviewed that a little bit in the last lesson, but here that'll be our main focus. So one of the first activities they asked us to do is to fill out the outputs, which is this column right here, and then the first differences and ratios. Notice here we're using the exact same numbers, 4 and 2, 4 and 2, 8 and 4, 8 and 4. The only difference is here we're subtracting, whereas over here, I know that dash looks a little different. We are actually dividing. So on your calculator, make sure to use the dividing symbol. Okay? So the first thing they ask us to do is just to calculate each one of these values out. So on your calculator, go ahead and write in 2 parentheses 2 parentheses exponent. If you're wondering how do I press that button on your graphing calculator, that button right there, which is usually right below the clear symbol, will give you that exponent that you need. After you type in that 0, go ahead and press enter, because there is no equal sign on your graphing calculator. And go ahead and compute those. Pause here if you haven't done so for each of these terms. And unpause. These should be the terms you should have gotten. And then what I'll do is find the first differences and ratios. Again, pause here if you need to, so you can compute all of these first differences first, and then all of these ratios. And unpause, we should have gotten this and this. You'll notice which column of numbers is constant. Exponential, right? For the next activity, they have us do a word problem, or comparing two prizes that we've won. Oh yay, free money! So it says you start with $50 and then add a fixed amount. So a fixed amount means you're going to get that same amount every single month. This is the constant change. This constant change is a fixed amount of growth. It means you're not getting more than $10 each month. You're just going to get that $10. And that equation is shown by what we start with, which is that $50, and then what we get each month. The reason why it's adding is because we are growing. Alright, the next thing they're going to ask you to do is fill in a table of values. So that you can do that, I'm going to show you what buttons you would need to choose on your graphing calculator to get a table of values. So first you'll see this is my graphing calculator. We're going to go ahead and press y equals, which is highlighted right here. The next thing we're going to do is we're going to type in this equation. Alright, now a lot of students are able to put in the number part and the addition part. They kind of are not sure, where do I find this x? Just so you know, next to your green key is the x button. Once you finish typing it in, you're like, now what? What you're going to do is press second, which is in blue, and then the graph button, because you'll notice right above it is the word table in blue. a table should appear. Again, pause right here because I want you to try and write that in and make sure you're able to do this. But we are going to correct to make sure that the values are correct. So pause and unpause. These are the values you should have obtained for that equation. I know it's a very long list, but we will survive. Alright, so you can see it builds very quickly. Alright, so the second prize, prize B, it says prize B, you start with $50, so the same amount. We're going to still start with $50. And then you add 10% each time. So 10% means it's not going to be the same amount each time. It's just going to be 10% of whatever that is. So it is going to be an increasing amount. Some months I might get $5. Some months it might go up higher than $5. It might go up by 10, 15, 20, 30. So it's an increasing amount, which means more money, which is pretty awesome. So you'll probably notice, why did they get 1.10? So that 1 denotes the $50 that you start with, whereas the 0.10 is that 10% as a decimal. Alright, again, we're going to type this into our graphing calculator. Oh, one last thing. You'll notice that x is in the exponent position. Okay, again, we're going to go ahead and type this into our graphing calculator. So again, go ahead and press y equals and type this equation in. If you're not sure how to make the x an exponent, just so you know, that button for the exponent is actually right here. Just so you can see where that is. You'll want to press that before you press x, just so that you make sure that that x is in the exponent's place. Once you're done with that, oh yes, I do label it. Awesome, cool. I thought I was gonna miss that. Okay. The next thing you'll do is press second graph, so you can create a table of values. Again, pause here if you need to, so that way you know that you can create this table of values without me giving you answers yet. And unpause. These are the values you should have obtained. So notice that it does grow rather quickly. And at some month in here, it does kind of will beat out prize A. In fact, after the 15th month, if you're willing to wait that long, prize B does become bigger, and it just the difference between them becomes even larger. So it says, if the prize only pays at 6 months, which prize is better? So let's locate 6 months and make that determination. Which number is bigger, has more money. And then if we wait until the 16th month, yes, I already gave you the answer away, but make sure you make that determination. So I'm going to pause here. If the prize gives you a prize pays for 16 months, which is a better prize? And it looks like prize B is better. There is a question asking you which prize would you choose. So here's a little sentence starter. Oh, that shouldn't say job, that should say prize. Spoiler alert, the next one might be about jobs. So I would choose prize and why. So there's benefits to both. Here you get more money up front, whereas if you're willing to wait, I know it's a long wait, but if you're willing to wait, you'll get more money in the long run. Okay, moving right along. Here's another word problem. Oh, see, I told you. Spoiler alert. It's going to be about jobs. Job A is going to pay us $75,000 for the first year. That's not bad. And then $5,000 every year after that. Whereas job B is going to start a little lower for the first year, but they're going to give us an 8% raise after that. Remember, that's going to be an increasing growth, whereas this is going to be a fixed growth. So again, we're going to create an equation. So I kind of wrote out this outline for you. graphic organizer. So y equals, again, you're identifying that information. Your first year's money. Now they do give us a raise, so is that going to be an adding or a subtracting symbol we're going to put in? Well, we're going to put 5,000 there, but that's going to be an adding symbol. For the second one, it's going to be $55,000 for the first year, 8% raise every year after that, which is why we're using a different equation, because this growth, again, is an increasing growth. Alright, so here we'll write 50, and it's a raise, so it is a growth. So our first year, we're going to go ahead and put in that much money. Again, deciding if it's going to be positive or negative. If it's a raise, I'm sure they're going to be adding that to our salary. And then we're going to change 8% into a decimal. One way we could do this is writing 8 divided by 100, so take some time to work that out. And I got this. Hopefully you got the same thing. Now we're ready to make our table of values. So again, just to review how we would use our graphing calculator, go ahead and press y equals. Go ahead and type in the equation, and then press X if you need to know where that is again. The next thing you'll do is press second table, and you should create a table of values for that equation. Alright. For this one, pause here. I'm not going to show you the answers just yet, but try it out. And you should have gotten this. And I'm going to add one more column. You'll see why at the end of the problem. For job B, we'll do the same thing. Let's go ahead and write in y equals. Let's go ahead and type in our equation. Remember where x is. Remember where that exponent key is. Then after you type it in, you're going to press second table and create a table of values for that one. So again, pause here before you see a list of job B's numbers. But here they go. And you'll notice here it says why I added that extra row, because the next question it's going to ask us is, when will job B be more than A? After about how many years does that happen? I'll let you fill in that sentence starter. And then again, another sentence starter of which job would you choose and why. Alright, moving right along. We're going to be determining whether a linear or exponential regression model for the data is going to be used to describe this. So you'll notice here for first differences, I put my first number first, then my second. Notice how I'm using the exact same numbers. Okay. For dividing, get my first number first, and the one before it. And I'm going to write the same thing here. First number first, the one before it. And I'm not going to do all of these for you, but go ahead and fill out your table. Go ahead and calculate these out. I'm also not going to give you the answers for these, so we're going to move it right along. Once you do finish your columns, though, oh, I guess I am actually. Never mind. So before I continue, if you haven't done this already, pause here before you check them. Alright, so it looks like these would be our numbers. And those would be our differences. And for here, we use the same numbers, just dividing them. And you'll see that these would be our ratios. So looking at both of these, neither one seems to be constant, but there is a column that's more closer together. So do you think it's first differences and it's linear? Or it's going to be ratios and exponential? So to make your determination there, if it's going to be first differences or ratio, or if it's linear or exponential. And if you're like, I can't read that, it's listed right there. You can copy it down. So before we continue on to the next problem, I'm going to go ahead and pause here. Stay tuned for part 2.